So good morning everyone. So today we are going to discuss the 2017 organic structure question. Okay. So the question is the alcohols A, B, C and D are structural isomers of each other having the molecular formula. So they have given all of them are alcohols. And the formula is C5H12O. So we discussed 2020 question and all this. Similar to this, first what we do? First we maintain the functional group in the terminal position and change the carbon skeleton. After that, keeping the carbon skeleton fixed, we are going to change the what? Position of the functional group. Those are the possibilities of these isomers. So first of all, there are 5 carbons. I am maintaining the OH in the terminal position. So first I am going to change the carbon skeleton. So I am going to remove this one carbon. Okay. Then there are 4 carbons in the main chain. So if I attach this carbon here, same skeleton will come. Then I will attach it here. Then I can attach it here, attach it here. So another 2 more. So this is one. So another one I can attach in this carbon. Okay. Then what I can do? Then I can remove 2 carbons. So if I remove 2 carbons, carbon, 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 OH. Okay, I'm removing these 2 carbons and individually I'm putting carbon. Or else in the same carbon I can attach what? These 2 carbons. This is one structure. So another one is this is one structure. Then if I remove 3 carbons, then there is only 2 positions, so no possibilities. So these are the possibilities, maintaining the OH in the terminal position and changing what? The carbon skeleton. So next one, what I can do is, I can change the position of OH. So when you are changing the position of the functional group, sometimes what happens, you can get the same skeleton. Then we will cut it off. So this OH, I can put it here or here. Okay, there are 2 more structures possible. So OH here or OH here. Because now when you consider these 5 carbons, carbon, 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 this carbon and this carbon are identical. If you put OH here or OH here, same skeleton. If you put OH here, OH here, same skeleton. So that's why one possibility is this, another 2 possibilities are here. Okay. So first, what they are telling is the alcohols A, B, C, and D are structural isomers of each other having the molecular formula C5H12O. A, B, and C show optical isomerism. So they have given you a key point here. All 3 show optical isomerism. Then we can reduce the structures. We can cut out the structures which doesn't show optical isomerism. Now, if you consider this structure, see, no optical isomerism. 2 hydrogens, everywhere hydrogens. So this structure doesn't show optical isomerism. Now, if you consider here also there are 2 hydrogens possibility, no. So if you consider this carbon CH3, CH3, therefore it doesn't show what? Optical isomerism. So when I consider this structure, this carbon it shows optical isomerism. See CH3. This is another R group and H. So this will show optical isomerism. If I consider this carbon, yes, see there is one group here. There is another group here, different group. So hydrogen. So this will show optical isomerism. So if I consider this carbon, so if I consider this carbon, see CH3, CH3. So it won't show what? Optical isomerism. But if I consider this carbon, R group, OH, C, hydrogen. So this will show what? Optical isomerism. This one, no. Hydrogen, hydrogen, this carbon. This also same group are there. So this won't show optical isomerism. Similarly, what? This also won't show optical isomerism. Okay. So when you consider this structure, here see both are same structure. See 3 carbons, carbon, carbon OH. Similarly, carbon, carbon OH. Therefore, we can cut off this structure. So that's why when you are after drawing the chain, when you are changing the position of this functional group, sometimes you will repeat the same structure. Then you should cut off. So this one, if you consider, it doesn't show. Why CH2, CH3, CH2, CH2H. So this also doesn't show optical isomerism. Therefore, only 3 structures show optical isomerism. So you have to draw those structures in the first 3 boxes. So they are asking draw possible structures for A, B, and C. Okay. So what are the possible structures for A, B, and C? One is CH3, CH2, CH2, CH3H. Another one is CH3, CH2, CH, CH3, CH2OH. So another one is CH3, 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 CHOH, here also CH. So these are the possible structures for A, B, C. So next one, what they are telling is, when B, C and D are reacted with acidic K2Cr2O7, X, Y and Z are formed respectively. Okay. So we are treating B, C, D. All these with acidic K2Cr2O7. Acidic K2Cr2O7. What we are getting is X, Y and Z respectively. The products X, Y, Z can be converted back to BCD respectively by reacting with sodium borohydride. So this X, Y, Z can be converted back to the BCD by reacting with what? Sodium borohydride. Okay. Now BCD are what? BCD, all three are alcohols. Alcohols, when you add acidic K2Cr2O7, okay, for alcohols, when you add acidic K2Cr2O7, if it is a primary alcohol, it will give carboxylic acid. If it is a secondary alcohol, it will give what? Ketone. But for ketone and carboxylic acid, if you add sodium borohydride, ketone will give back the alcohol. But carboxylic acid, you can't reduce with what? Sodium borohydride, nothing in reaction. Now to reduce carboxylic acid, we need lithium aluminium hydride. That means BCD, everything can react with acidic K2Cr2O7 and it can be converted back using sodium borohydride. But A, they didn't tell about it. That means what they are saying, A doesn't you can't take a conclusion like A doesn't react with acidic K2Cr2O7. It might react, but with sodium borohydride, but it cannot be converted back. That means what? A should be what? A should be a primary alcohol. So see what are the possibilities? This is a secondary alcohol. Why? Carbon which is attached to it has one hydrogen and two argons. Now this is primary alcohol. See, therefore this is what? This is the structure of it. Now we figured out the structure of it. Because when you consider other structure also, it is also what? A secondary alcohol. Therefore this is it. Okay, then they are asking the question, what is the structure of it? Then you should draw this in the box. CH3, CH2, CH, CH3, CH2OH. Okay. Then next part what they are telling is, on heating with concentrated H2SO4, A and B gave E and F respectively. So for now we know this is E. Okay. For A, what I am going to put is concentrated H2SO4. It gives E. So concentrated H2SO4, what does it do? So okay, carbon here OH, it will remove the hydrogen from here. So this OH and this hydrogen gets removed, then you will get CH3, CH2, C, CH3, double bonded CH2. So this is the structure of what? E. So they are telling on heating with concentrated H2SO4, A and B gave E and F respectively, while C and D gave the same product G. G shows diastereomerism. Okay, now B, we still don't know which is B. Okay, there are two possibilities. This can be B, or this can be C, or this can be C, this can be B. To distinguish B and C, we didn't still get any idea in the previous paragraph, but now they are giving some idea. See, while C and D give the same product G, G shows diastereomerism. All three compounds E, F, and G have the molecular formula C5H10. Okay. When E and F are reacted with HBr, the same product H was formed. Okay. Now the thing is, we don't have anything to distinguish between B and C. Now I have to go backwards. Now you see, they are talking about G. While C and D gave the same product, G shows diastereomerism, and G's formula is given C5H10. Okay. Now what I can do is I can draw G. G is what? C5H10. It should show diastereomerism means what? Carbon, carbon, double bond should be there definitely. Okay. Then 2 carbons I have taken it. Now 3 more carbons remain. Then what I can put? I can make a CH3. Okay. So I can make a CH3, a CH2, CH3, a hydrogen here, CH2, CH3 I can make. So this is my only possibility for G. Isn't it? Now you see, we are draw with 5 carbons. No? So carbon, carbon, double bond. Already 2 carbon, only 3 carbons remain. Okay. Then if I put CH3 here and another CH3 here, it won't show geometric resonance. Therefore, one should be 2 carbons, another one should be single one in hydrogen. Now this is G. Now what they are telling is C and D gave the same product G. C and D gave the same product G. Now, this is what? This we have an alcohol. So there are only 2 possibilities for C. C and this can be C or this can be C. Now you must go from behind. This one can be formed from 2 types of what? Alcohol skeletons. So what are the 2 types? So one is this possibility, another one is this possibility. So one could be which one? CH3, CH2, okay, CH2, CHOH, CH3. Or else it could be CH3, CH2, CHOH, CH2, CH3. So one skeleton should be C and one skeleton should be D. C shows what? Optical isomerism. D doesn't show what? Optical isomerism. Therefore, this should be C. This only shows optical isomerism now. Where is that C here? Here it is here. Okay. This is C, so this is D. So D doesn't show optical isomerism. We had only 2 possibilities. So one could be this one and one could be this one. So this is our, okay. So yeah. CH3, CH2, CH2, CHO and CH3. See CH3, CH2, CH2, CHO and CH3. So this is our which one? C. Already I put a tick for optical isomerism. Therefore, this one should be what? Our B. Now we identify A, B, C, D, E, everything. Okay, then we can, if I know my B, I can write F also. F comes from what? For B, treating with concentrated H2SO4. For B, if I add concentrated H2SO4, what will be my product? Now, this carbon which is attached to OH, this carbon has lowest hydrogen, this one. So it will remove from there. So CH3, carbon, CH3, okay, double bonded CH and CH3. So this will be my F. Okay. So next what they are telling is when E and F are reacted with HBr, the same product H was obtained. So E I am treating with HBr, then what will be the product? HBr means hydrogen will come here, Br will come here. According to Marconi's rule. CH3, CH2C, CH3 here, CH3 here, Br here. So this is my H. The same product they are telling when you treat with F also it will get. Okay, no need that data here. We are already identified, right? CH3, CH3. Okay, Br here, CH2, CH3 here. See, same product. CH2, CH3. CH3, CH3. And Br. Okay, that we call as H. So they asked to draw the structure A, B, C, D, E, F, H. So we have drawn everything. So next part of the question, draw the structure of the diastereomers of G. That means now this is trans, right? Similar to trans, what I can say, I can put the hydrogen here and draw another one that we call as a cis one. Carbon, carbon double bond, hydrogen here, CH3, CH2 here, and CH3 here. So this is what this we call as a cis structure. Okay, I hope you would have understood this. Thanks for listening.